Good morning, everyone. My name is Nick Militich, and today I'll be talking about SAP on AWS and why it's a solid platform for running your SAP landscape. A little bit of background about myself. I've been in the SAP basis realm for almost 15 years, and I'm a certified AWS solutions architect as well, so very familiar on SAP and how it runs in native hardware and how to design it for AWS. So today I'm going to touch on why is SAP on AWS a solid platform. Now, a few key areas here. AWS for SAP, in the past has generally been used for training environments or maybe your non-productive environments, and that is kind of a misnomer. They really have made significant changes, and it is and has been over the last several years a solid platform for running your entire SAP landscape and traditional non-SAP workloads as well. Now, why AWS for SAP? It does have an extensive infrastructure, so it's global footprint, multiple redundant data centers within regions, which I'll get into in the presentation as we go along. There's also flexible payment options and terms. So traditionally, you have your standard payment options and a fixed fee with private managed clouds. Well, with AWS, you have on-demand, pay-as-you-go type models. AWS also offers additional features such as APIs to connect into and manage your environment, AMIs, which are machine images, so pre-canned solutions that are already built and can include AWS and SAP installations. And there's a lot of scripted deployments as well that AWS offers that allows you to deploy SAP landscapes very, very quickly. And there's additional technologies that AWS and Amazon offers in addition to just standard, server instances. They offer analytics. They offer additional products such as their RDS solutions, which are deployable pre-canned databases. So there's a lot of different features that AWS offers that you can leverage in your organization. So the key areas of focus today that I'm going to talk about are what can you run in AWS? What products are supported? Then I'm going to go into the supported AWS technologies. So there's only certain things that are supported in AWS, certain SAP products. I'll talk a little bit about the network design and how that plays a critical role in deploying your environment. I will also touch base on the security aspect of your environment. I know that's a hot topic today for a lot of individuals. And then additional considerations when you run SAP in an AWS infrastructure. I will then go ahead and show you a complete landscape overview. So I'll give you examples of what a complete SAP landscape looks like in AWS, and then some HA and DR options when you design your environment in AWS, and then how do we get your data into Amazon. So I'll give you a few migration techniques as well. So I tried to tailor this webinar to make sure that everyone can understand what I'm talking about when it comes to AWS. And just like SAP, we all know we love the three-letter acronyms. AWS is really no different. They have their own type of acronyms as well. So although I will be touching on these, I wanted to kind of give you an overview of what some of these technologies are. So as I go through this presentation, for the people on the call that may not be as familiar with AWS, you can get a sense of what I'm talking about and how to correlate it to. So quickly, EC2, when I talk about EC2, it's Amazon's Elastic Compute Cloud. That is the server portion of AWS. So when I talk and say EC2, you can think of it as the server. EBS is Amazon's Elastic Block Store, so that's block level storage. That is your traditional SanDisk that you think of when you go into a traditional data center. That's the disk that we would use in AWS to run your database. You run your SAP. It's built for performance, and it's built for really high throughput. And you can think of it maybe as SSD, although there are SSD options in EBS, which I won't go into today. EBS is your main disk. S3 is your inexpensive data storage. So that is different than EBS. It's used for storing flat files. It's not made for performance. It's made for quantity. It's made for redundancy. So we would use these in an AWS environment to store your backup files, for example. And it's very inexpensive disk compared to EBS because of the performance differences. However, it is absolutely perfect for storing, flat files, installation media, backups for 30 days. Something of that nature. I will get into the next two, actually the next three in more detail. However, just for a quick recap, a region in AWS is a geographical area comprised of multiple availability zones. So, for example, the closest one to the managed core location would be Ohio region. That one has multiple availability zones. An availability zone, you can think of it as a data center. It's a location within a region. So you have a geographical region, pick Ohio, and within there you have multiple availability zones or multiple data centers spanning that region. And then a VPC, which is very critical to how AWS works and how you would configure your environment, is a virtual private cloud. You can consider this your data center. So you build a VPC, and within your data center, your VPC, you're going to include subnets, public and private. You're going to add your EC2 instances or your servers and add storage and et cetera. You will have all of that built into your virtual data center, which AWS calls a virtual private cloud. Okay, so now moving on to the details about SAP. So what can you run in AWS? So there are a few solutions that are allowed in Amazon, and I will be focusing on the first two in particular, but you can run SAP HANA, including S4 and BW. You can run standard SAP Business Suite, so your ECC environments running SQL Server or Oracle, for example. And then the other additional components are SAP Hybris, SAP Business One, SAP Business Objects, and then other database and mobile solutions. And it changes all the time, so I did provide a link here so everyone can kind of take a look and see what the latest solutions are. But like I said, we'll be focusing on the top two, so SAP HANA, specifically S4, and SAP Business Suite. So now kind of getting into the supported technologies in AWS. Keep in mind that different AWS products are supported within each SAP solution, and not all combinations are supported. So for example, even with SAP Business Suite, ERP 6, for example, ECC 6, you may only have certain products that are supported within that in certain versions. And I'll get a little bit into it here, but SAP note referenced on the screen here, SAP applications on AWS supported DBOS and AWS EC2 instance products. That note will give you the latest information, so please do go check that out as you're looking at deploying SAP in AWS. Key takeaways, I did reference a few key takeaways here for you. Number one, AWS RDS is not supported with NetWeaver solutions. So keep that in mind. I'll get a little bit into licensing as we go on through this presentation. However, you cannot use an AWS RDS instance. And RDS, for the folks that aren't familiar with it, is Amazon's database solution, meaning they sell you basically a database. You can purchase SQL Server, for example, from Amazon and use that. And that is not supported. It's not supported methodology with AWS and SAP. ABAP and Java systems on SAP NetWeaver 7.0 and higher are supported. So, it goes fairly back. You're not going to get your 4.6Cs on here, but, your 7.0 and higher are definitely supported. In this note, it does include all the supported EC2 instances. If you actually look at the bottom link, there's some HANA hardware as well that kind of shows you the the HANA supported instances, but in this note you will also find the non-HANA supported instances. They also include the equivalent SAPS ratings. So for those of you that would generally look at your organizations, try to scope out your next platform, what you can do here is you can go to this note. It will tell you the SAPS ratings for the different instance types in Amazon, and you can compare that to your current hardware. So it gives you a really good gauge of, if I were to run it on an R3 extra large instance in AWS, what is the SAPS rating there, and is it the equivalent to what I'm running today? For example, Dell 930, maybe you're running on premise. You can get the SAPS ratings for both and really compare and understand what you're putting your environment in. AWS Elastic File System, it cannot be used for database and files or log files. It just doesn't have the performance of EBS. It's not a supported file system. One note for our Oracle customers. So Oracle is supported on AWS, however, only with Oracle Linux. So keep that in mind. I know traditionally, just what I've seen in my experience, not a lot of on-premise companies run Oracle Linux with Oracle. If you do, you're covered. If you don't, keep in mind that you'll have to change OS platforms if you want to continue to use Oracle in AWS running SAP. And SUSE, Red Hat, and Oracle Linux and Windows are the 4 supported platforms. So you're not going to get your AIXs or the HPUXs. They just don't work in AWS. But all the common Intel-based platforms are readily available in AWS. So now I'm going to go into a little bit about the network technology and the design of the network in AWS. I know that's critical. Connectivity. People always want to know, how do I connect to AWS? So I'm going to start with the connection options. There are 3 standard options when you're connecting to AWS. One is your standard direct internet connection. So that's probably how most people today connect to AWS that are maybe playing around with it, trying to test the waters, seeing how it works. AWS offers public IP addresses to the servers that you deploy, and you can get to it just via the internet. We all know in the SAP world, we don't want our SAP environments publicly facing, so generally if you're going to do this, it may be for a demo system with no data or a demo system without your data, just so that it's safe. Those are the type of connections that I would see using a direct internet connection. I would not recommend that for productive use. For productive use, the next 2 options are the most commonly used. The first one is your standard VPN connectivity. So you can put a VPN tunnel to AWS, and you can connect your environment just like you would anywhere else, just like a remote office using a site-to-site encrypted IPsec tunnel. And that, again, allows you to communicate just as you would and any VPN tunnel you'd set up today, not to AWS. And the third option is AWS Direct Connect. It's actually a product from Amazon. Now, it is the best option for maximum bandwidth requirements. So if you have high bandwidth requirements, I do recommend that you look at AWS Direct Connect. That allows you to drop an actual dedicated circuit into a Direct Connect facility nearest your AWS environment. So very, very convenient. If you're used to dropping an MPLS at corporate sites or at other data centers today, you can drop an MPLS circuit at a Direct Connect site, and AWS then can connect it to your environment, and you will have a dedicated connection. So much more convenient if you have MPLS today or if you have high bandwidth requirements. So now I'm going to get into the nuts and bolts of actually networking within AWS. And it all starts with a VPC. If you remember from the first few slides, VPC is Amazon's virtual private cloud. It is the building block of your SAP environment, and you can think of it as your virtual data center. So what it does is it completely isolates your environment from everyone else, and it makes it a completely private, again, data center. I mean, you are really deploying a data center concept here when you deploy a VPC. There are controls, which I'll get into in the next few slides, but the main two controls are security groups and network access control lists. So they provide the mechanism for securing your environment, both on the network side, on the subnet side, and on the EC2 instance side, so individual servers. Within the VPC, subnets are configured, so you can include multiple private subnets, you can include public subnets. The designs are pretty much unlimited. I mean, they're only limited to what you can design, and you can design and follow your current corporate policies if you have them. This one, for example, if we look at the diagram to the right here on the screen, you can see if you start at the bigger bubble, the rectangle is AWS, so consider that a region. So again, going back to a region, let's say that was the Ohio region. Your region is Ohio. If you look at the dotted line, you have availability zone A. That is a data center within that region. And within that region, you then have your VPC. So that's the next rectangle there. Within that VPC, you have two subnets, a public subnet and a private subnet. And you can divvy out your environments that way. So for the public subnet, you have the outward-facing web servers, you have a NAT gateway, and that NAT gateway in this design allows you to communicate back to your private subnet. So what that does allow is it allows segregation of environments, and you can think of that as a DMZ, for example. That's your traditional DMZ concept. So now I'm going to talk a little bit about the environment and the security and how you keep your system safe. And I'm going to start with the type of security that AWS offers and what type of model they have. And Amazon really adheres to what they call a shared responsibility model. And I'm just going to read the first sentence of the verbiage from the AWS site, but AWS does say, while AWS manages security of the cloud, security in the cloud is responsibility of the customer. So what does that mean? If you look at the chart to your right, AWS is responsible for securing the region, securing the data centers or availability zones. They're responsible for securing the facilities and hardening the network and the storage, the compute, everything that goes with it from a physical standpoint and down to that layer. It is the customer's responsibility of whatever they put in the cloud needs to be secure. So, customer applications, the OS, for example, securing access to the EC2 instance is a prime example. AWS offers security of the EC2 instance, but getting access to it and securing that is the responsibility of the client. So that's really where the line of delineation is, and it's a little different when it comes to AWS, and their model is definitely a shared responsibility model. So keep that in mind when you're designing an environment within AWS. So AWS, as I mentioned before, provides a few tools to manage your access. And the two main tool sets are security groups and network access control lists. So security groups provide access at the instance level. And by instance, I mean EC2 instance, or what we consider, a server. So just like a firewall, you control inbound and outbound traffic. It is a little different that by default, a security group doesn't allow any inbound traffic. So a few things to take into consideration when you're creating security groups. And you can also allow rules, but you cannot deny rules. So a few key areas to understand when you're trying to give access at the server level. If you take one step backward, you go to the Network Access Control List, or ACL. Again, similar to how you would control a firewall, but it controls it at the subnet level. So at the subnet level, you allow inbound and outbound traffic to each subnet. And a few key areas there. Keep in mind that by default, all traffic is denied when you create a newly configured ACL. So if you go in there and you create one and you wonder why no one can access it, it's because everything's denied out of the gate. And a little different to security groups, ACLs, those rules are evaluated in order. So be careful. The numbering scheme matters. So rule number 1 will go, and then rule number 2 will go after it. So make sure that as you go through those rule sets that you're not overriding your rule sets and wiping out what you previously put in a higher up rule. So if we take the security groups and the network access control list together, the ACL starts first, and you go and have access to the subnet, and then once you get into that subnet, the security groups take over and allow you to get security at the instance level. So I'm going to talk about some additional considerations when you run SAP on AWS. So please reference the note that I have in here, SAP on AWS support prerequisites. That is a very critical note. Anything and everything you need to know on running SAP on AWS and how to deploy it is in that note. And AWS itself has a great SAP site and a lot of white papers on their site, very easy to navigate. You get installation, implementation, operation guides, anything you need to know how to deploy SAP on AWS is on that site. SAP installations, when it comes to deploying those in AWS, they do have some pre-built images. So again, images, we'll reference those as AMIs as well, Amazon Machine Images. And those images do include, some of them, certain levels of SAP installation. So you can get an ECC6 installation built on an AMI, and you can deploy that right out of the gate. Keep in mind, there's only certain images. They don't have every version, so you may be a few versions behind. However, they do offer those images. Amazon also offers a HANA deployment tool which configures your entire landscape, so very, very convenient. It includes deploying the VPC, all the standard security groups and access control lists. By default, it includes configuring the EBS storage, the servers, meaning the EC2 instances, and it really, within an hour or two, you can have a HANA environment deployed and ready to access, so very convenient. You can even preload certain HANA binaries and certain HANA media from SAP. You can upload it to an S3 bucket, and you can actually have this deployment tool install HANA. Now, keep in mind when I say install HANA, it is the database. You will still have to go back and install SAP, but it does deploy HANA for you. And it really is convenient. I mean, imagine the days when you would, in a traditional data center, you're deploying network gear, you're deploying the SAN, you're getting all that ready, and eventually in a few weeks you have a data center stood up. This is essentially deploying a VPC and all the infrastructure inside it, which is just like deploying a data center, just virtually, and it's done within an hour or two. So the speed and the time to get this up and running has been significantly reduced in AWS. A little bit about SAP and database licensing. So it can vary by product, but for the terms of S/4HANA and Suite on HANA and just standard business suite, they do have a bring your own license model. So any license you buy from SAP, you just port it over to AWS. They do have on-demand and trial and developer licensing that you can get as well. But if you currently are running SAP, you can just bring your own license. And same for the database licensing, it's bring your own license. So whether you purchased it from SQL Server from Microsoft or database from SAP directly as part of your contract, just bringing that license with will work. Now, I do want to focus a little bit about regions and availability zones. I want to make sure that everyone understands that concept because it is critical in deploying SAP and especially within the AWS infrastructure because Amazon does use these terms quite a bit. So again, think of availability zones as physical data centers and regions as a grouping of multiple data centers. So if we use the Ohio example, Ohio is a region, and within that region you're going to have multiple physical data centers located within the few 100-mile span that it would probably span, and you would actually be in different physical data centers. Why is that critical? And I'll get to that when we start deploying HA and DR, but you can have effectively your environment spread in the same region, so in Ohio region, for example, across multiple different data centers. And that could constitute HA. And then when you get into a DR environment, you could span in different region. So you could go from Ohio to Seattle, for example. You could have multiple availability zones and multiple regions. Also, regions are very critical when it comes to deploying SAP infrastructure. You want to make sure that you choose a region that, one, has the capabilities you're looking for, because not every AWS product is supported in every region. So keep that in mind. The other piece when it comes to regions is that you want to have the location closest to your corporate facility or where the majority of the users are going to be. So if you're on the East Coast, but you have a corporate headquarters at the East Coast, but most of your employees are on the West Coast, you probably want to choose a region that is slightly closer to the West Coast, so you get better response time. So regions do matter, and from a design perspective, you should take those into considerations. So now I'm going to give you a few examples of what a complete landscape looks like of SAP in AWS. So the first example I'm going to give you is a hybrid example. So this is the most common as clients are trying to test the waters of AWS, or just get a feel for what does SAP look like in AWS. So in this example, your production landscape is on-premise, and you have your dev queues and sandboxes within AWS. Now in this scenario, you'll see that we are in a VPC in a single availability zone, that's the dotted line, and then you have one single private subnet. These environments don't have to get out to the internet, so there was only one private subnet, and you have a VPN connection between the two facilities, so AWS and your corporate facility, and you are running those environments within AWS. Again, just QAS, dev, and test. And private subnet. Those are the key things to take away here is we're putting this in a private subnet, and you can run it standard VPN connection. Now this next slide shows a complete landscape, and I will touch base on the key differences here. So as you get into deploying your whole SAP environment into AWS, there are a few different key considerations. If you notice, there's actually now a public and private subnet. We're still within one availability zone because we're not focusing on HA or DR here. So one availability zone, one VPC in a public and private subnet. We still have a VPN connection. You can replace that with a direct connect as shown here as well. So that's either an MPLS circuit or a VPN connection. Your private subnet contains all of your SAP landscape. They are not accessible via the internet. We then deploy a public subnet, and that includes your SAP router. It includes a NAT instance, and what that NAT instance does, or NAT gateway would do, is it would actually serve as a DMZ for all intents and purposes and route traffic that might need to access these environments publicly through that NAT instance into your private subnet. So there's no direct communication between public and private subnets other than the rules you put in place. Now this is for security reasons. Obviously you don't want anyone accessing your environment through the internet. And what this also allows is, for example, your production instance to go through that NAT instance in the public subnet to get EDI files or some FTP files. So that this is how you would do that implementation if your system still needed access to the internet, but you wanted to significantly reduce your risk. Now, this example is a HANA example. It's a little more detailed, and I'll go into the reasons why here, but it is very similar to the other designs. We have your availability zone, you have a public subnet, and you have a private subnet. So within this environment, you can see that there's HANA here with the orange cubes. Nothing is accessed through the public subnet. Everything's done here. They have an internet gateway. You can still do it in this fashion. It's kind of a different type of access. So, for example, you'll notice that there's an RDP section with the people kind of toward the right-hand side there. And what they do is they actually go into the RDP instance in the public subnet and then can access HANA through there. So that's a little different way it's kind of a hybrid model. It's not quite VPN, IPsec configuration, but it's also not completely publicly available. In this example, the RDP instance is publicly available, and if you have access to that, you can then use tools to get access to HANA. This is more of for a demo system as well. I would, in a true complete deployment with a productive instance, I would do a MPLS, Direct Connect, or a VPN tunnel and have a traditional connectivity in that fashion. If you see here, some key differences is this does show the breakdown of disk. Everything within the private subnet are your EBS volumes. So if we go back to the disk discussion at the beginning in EBS versus S3, red squares or rectangles there, that is your EBS disk. That is the fast disk that everything's going to reside on that runs SAP HANA. If you notice on the outskirts, you'll have an S3. And that S3, they call them S3 buckets. And those buckets are to put HANA media, so anything you download from SAP that you need for installation and backup snapshots. So in the HANA realm, you're doing a backup to EBS, and you're taking that EBS data and then moving it to the S3 backup bucket, and then you can set retention policies that after 30 days you delete anything older than 30 days. So AWS offers that complete line of technology from start to finish that allows you to do backups, for example. But this is your standard HANA design. So I'm going to get into the HA and DR options when deploying, within AWS. So a few key differences to think of. Everyone thinks that AWS is, because it is the public cloud and it has a lot of data centers, a lot of infrastructure that it inherently provides HA and DR. And that is not quite the case. AWS provides highly redundant data centers and multiple geographical regions. So they provide you the building blocks for really doing any type of HA and DR that you can think of. It is up to you to determine the proper way to do HA and DR. So again, think of AWS as providing you the infrastructure to make it happen. However, you have to deploy it yourself. And again, availability zones and regions, you'll have to figure that out as you deploy it, and it's per business. So there may be a reason to do HA in a certain particular region. There may be a reason to DR it to a different region completely. And you would have to choose those as you go through that. However, again, keep in mind you have to design it yourself. And I'll show you in the next few slides a few different design considerations. So here is a design for SAP HA and DR. And I will explain it here in detail. So if you look at the diagram, on the left-hand side where you see region A, that bigger rectangle, that is HA. If you notice in there, region A has your environment within a single VPC. And again, that's critical. You can put multiple availability zones in that VPC and make it seem like HA. I mean, it is HA, but that's a little different concept in the traditional HA sense because you're deploying HA if you were to do it on premise, you're deploying it most likely in the same rack, and at the most maybe on different racks in different rooms at a single data center. With Amazon, you can deploy it in different availability zones. So again, remember, availability zones are different data centers. So I'm actually doing HA because of Amazon's robust backbone. I'm doing HA between different availability zones, different data center locations. So very, very convenient, very, very redundant. If I needed to do DR, I move to region B, and you can see that as you move to the right of the diagram. It's a separate VPC, so a separate virtual data center, and you now have DR replicated in a completely different region. So again, if I use region A as the Ohio region, region B could be Seattle, I've now done DR across the country, or even across the globe. Amazon has regions everywhere in the world. You can do DR to Asia Pac or Europe, for example. HANA works in the same manner. The only difference being is HANA uses, for those of you familiar with HANA, HA, and DR, HANA uses their replication technology. So it's a little different in the deployment methodology, but the design is the same. You have one region with 2 availability zones for HA, and you have 1 availability zone in a different region for DR. So that's the difference with HANA, but very, very similar in the concept. So now I'm going to talk about a few different migration techniques. So how do we get your data into AWS? New installations, very straightforward, very easy. Again, pre-built images, pre-built AMI images with SAP installed on it are available. And even at the OS level, you're deploying images and you can then install SAP on top of it. So very simple on the new installations. They're done in minutes versus days of installing it on premise. They do have reference deployments available out there. So again, you use a reference deployment, it can go from start to finish with VPC, EC2 instances, EBS volumes. It can do everything for you within a few hours. Very, very easy to deploy net new installations. And you can do the traditional way where you install an OS, you deploy an AMI, it gives you the OS, and you install SAP on top of it. If you have an existing SAP environment, there are a few different options for that as well. So 2 possible options that are the most common are the VMware or VM export-import tools. As long as you're running ESX, Hyper-V, or Xen, and you have the prerequisites met, you can actually move your VM into AWS using their migration tool. Keep in mind, it is for smaller systems or systems that aren't as critical from a downtime, because that tool does migrate it. Systems have to be down when you're taking the export, so they are made for smaller environments. For your standard SAP migrations, you're going to more than likely perform just your SAP out-of-the-box homogeneous or heterogeneous system migration. So it's the standard method that everyone's been using for forever. It's the same type of methodology that you would use in here as well. You would go on your existing environment, take the export or move the database, get a copy over to AWS, and run the remainder of the import tool. There is also another program out there. It's the AWS FAST program. It was co-developed by SAP and AWS, and it's made to migrate SAP systems to HANA. And it really does, on the back end, utilize a combination of SAP's DMO process and an AWS deployment automation. So really, it combines the two to get your environment migrated very, very quickly, so you can try it in a sandbox or a test environment. The toolkit does allow you to do it. They're saying in less than 48 hours. That will be dependent on how many steps you have to go, and there are prerequisites that must be met. So keep that in mind. But if all of that's met, you'd be able to do this in 48 hours, which is very, very quick. So now we talked about the techniques of migrating your data, but how do you actually get the physical data to that environment? So I'll go over a few data transfer methods. So again, you can do standard internet connectivity where you connect up and you transfer it over the wire, no real difference than an FTP or something similar to that. We do recommend that that is done with environments that are 1 terabyte or less because the data transfer can take quite long. There is also a direct connect option that I've been talking about, which is your MPLS circuit or something of that nature, and that's for larger bandwidth requirements. And if you drop a direct connect and connect it to your environment, that will allow you much greater transfer flexibility. You'll be able to get your environment there a lot quicker with a direct connect. For very large environments, AWS does offer what they call snowball service. So that's their marketing term. But the snowball technology utilizes an appliance that's actually shipped to you. You copy the data, it is shipped back to AWS, and then connected to your environment, and the data will be accessible. That is faster for larger environments because the time it would take to copy the data is significant if it's a large environment. But keep in mind you have to include shipping times with that. So as you're going through this determination to figure out the best way to transfer your data, if you're going to go a snowball route, remember AWS has to ship it to you. You have to copy the data. Then you have to ship it back to Amazon. They have to hook it up. So keep that in mind. That does take time. We're talking a few days there. So something to consider if you're a large environment trying to get your data there and you're contemplating the snowball service. So my last slide really touches base on the support of this environment and how you design it and the architecture. Now, AWS, again, in the shared responsibility model, if you look at the facilities and infrastructure, that's really what AWS provides. They provide you the building blocks to deploy your SAP environment. You have to keep in mind that you still have to provide the support of that environment when it's in there. So resource provisioning, backup and restoring, patching of the OS, and all of that is your responsibility or the responsibility of a service provider, such as Managed Core. We have the capability to do those type of support models. But remember that as you go through your journey with AWS, the deployment model is different. So where you would traditionally have SAN and network engineers, consideration should be taken for possibly hiring or outsourcing cloud engineers when it comes to deploying in that environment, because it is different than your traditional allocating SAN, for example. So keep that in mind when you're deploying in AWS. Certified solution architects, certified engineers in AWS will go a long way in making you successful.